How video streaming works? The Video Engineering 101 series provides a conceptual big picture of online video, a flow of how online video moves from a source to a screen. Intended for beginners looking to build streaming media workflows and products and seeking to understand the terms, technologies, and techniques to succeed. Here's the agenda. We'll cover some key underlying concepts, then dive into playback, streaming delivery, and media processing. Here's the big picture of how a video you're watching goes from source to screen. Source and processing, where the video content is created and processed. Video delivery, how it travels across networks to reach you. Video playback, the final step, where the video plays on your device. Each part plays a crucial role in delivering a smooth viewing experience. But for learning pleasure, we are going to flip and go from screen to source. It's more intuitive this way. Video playing on screen, like right now, is called playback. It's the process of displaying a sequence of images, frames, on a screen at a rapid rate, typically at 30 to 60 frames per second. This rapid succession creates the illusion of fluid motion, transforming still images into a continuous video from our vision's perspective. And all this magic happens in a software called Video Player. This window you are looking at is the YouTube player. Different platforms have different players, like Netflix and Amazon have built their own. But most folks use generically available open source or paid players. The video player often feels underrated but delivers a punch. It is where the rubber meets the road, proverbially speaking. The functionality it delivers, technically and experience-wise, varies from platform to platform. That said, let's explore some common functionalities and technologies at work in a video player. We will cover UX/UI containers formats like HLS and DASH segment files, adaptive bitrate streaming ABR, manifest files, HTTP protocols. First, let's start with UX. Here are the players from YouTube, Netflix, and CNN. Netflix prioritizes subtitles and audio optionality, playback, rewind, and forward, making it full screen. YouTube, as you can see, also has subtitles functionality, not optionality, and it shows what renditions of file are available and allows you to choose a rendition if you prefer to do that. You also have options to cast to devices and make it full screen. CNN Video has fewer options. You can see the ability to swipe left and right to other videos, subtitles, etc., but largely more limited, reflecting that needs of the audience and the kind of short content being served. Other players, like our own free player at FastPix, allows you to change colors to match your brand, pick what features you want, etc. So full customization, which is radically cool. Let's take a quick look at how video moves to your screen from a source and what makes streaming smooth and high quality. First up, we have the video player. This is the app or browser you're using to watch, whether it's on a phone, tablet, or TV. The video player adapts to different devices and screen sizes to provide a consistent viewing experience. Next is the video playback URL, which connects the video source to the player. Behind the scenes, it relies on a master manifest file. This file is like a roadmap, listing multiple renditions of the video, different quality versions for different internet speeds and device capabilities. Each of these renditions has its own rendition manifest, guiding the player to the right segments or chunks of video for smooth playback. These chunks, usually in .ts transport stream files, allow for quick loading without buffering. To deliver this video efficiently, we rely on a content delivery network, CDN. The CDN acts as a network of servers worldwide, delivering video from the closest server to the viewer. This setup reduces lag and speeds up streaming. Now let's move on from UX and understand what happens when you play a video. Let's understand this by upping the inspect mode and having the network console up. Let's play the video and give it a few seconds. First up is container format. This file called .m3u8. This file format is for HLS format or HTTP live streaming. Second, how is the video retrieved from server? It is done by a segment of video. You see these .ts files. These are segment files. Essentially, the video being served is broken up into segments of 2 to 12 seconds and sent from distribution endpoint, which can be a CDN or a server, to the video player. These segments are played in sequence. Here is what a master manifest file looks like. The third thing you will notice is multiple rendition files, which we noticed in YouTube Player. Here you can see 480p, 720p, 1080p, etc. These rendition files are here to support what is called adaptive bitrate streaming, also called ABR. It is one of the most powerful but unnoticed technologies that power your modern viewing experience. The basic premise that ABR enables is this. For a viewer, it is better for video to be playing than buffer or stop. Sounds simple, but powerful. So in a default state, the player, depending on your internet connection, is not playing one video, but a combination of the videos to ensure an uninterrupted viewing experience. It will switch between multiple rendition files to deliver this. It is hard for me to show this here on a platform, but I can do this on a video QoE platform like FastPix video data platform. Here you can see that initially the video started with 1080p, then it changed to 480p, and after the internet speed became fast, it resumed to 1080p. Most folks won't ever notice this, but that is what it takes. If you are wondering about QoE, head over to FastPix video data page or other videos on our channel. QoE is used by most video providers to capture data and improve services. As you may have noticed in the FastPix session view, a ton of data is captured for every view, even if that view was a second long. QoE tools like FastPix video data are video superpower. Let's now shift to video delivery or distribution. So what happens when you hit play on a video? Well, the player uses a playback URL, which fetches the video from either an origin server or more commonly from a content delivery network or a CDN. They are the most likely source of your file because they are set up to enable quick delivery of large files to a globally dispersed audience in seconds. At the heart of it, CDNs are essentially a ton of servers located all over the world, close to large human populations or areas of activity that already have cached the video files and then quickly send the file to your device over the internet in your ISP. Most videos are delivered via commercial CDN, the common ones being Fastly, Cloudflare, Akamai. A few folks, though, like Google and Netflix, have their CDN. Let's now cover source and processing. What are the challenges which compels to process the video? Between a raw video and the actual videos you watch, there is a lot of tech involved. As you can see, raw video files are huge in size, posing unviable challenges for existing internet infrastructure. This poses several challenges, primarily related to data usage, internet connectivity, and device performance. The iPhone 15 models come with varying storage capacities, e.g. 128 gigabytes, 256 gigabytes, 512 gigabytes, and 1 terabyte. If the device has limited available space, attempting to download or stream a large file like a 3.8 gigabyte video may be problematic. Our current internet infrastructure is not nearly enough to support raw video files. Even if we did, our devices will struggle, and the viewing experience as we know today will be a quaint memory. But what it takes for a raw video file to reach your screen smoothly and seamlessly? Let's dive into the journey that each video takes, from the raw footage captured to the final stream you enjoy. Everything starts with a raw video file. This raw footage is unprocessed and typically huge in size, not yet optimized for online streaming. It's like a rough gem that needs to be polished before it can be shared over the internet. Now we move to encoding, where the raw video is processed. It is of two types, software-based and hardware-based. Encoding compresses the file to a manageable size while preserving as much quality as possible. This crucial step makes streaming possible by ensuring the file isn't too bulky. Next, we package the video into containers. Think of a container as a suitcase that holds not only the video, but also audio, subtitles, and other metadata. Common containers include formats like MP4 or MKV, and they're essential for making sure all components of your video play together in sync. The encoded video now undergoes transcoding. Here, the video might be converted from one codec to another, or adjusted for different requirements and device compatibility. Next, we've got transrating. This step changes the bitrate, adapting the video's data rate to fit various network speeds. A high bitrate is ideal for fast networks, but we need lower bitrates for slower connections. Next, we've got transizing. In some cases, we also adjust the resolution of the video, known as transcoding, so that viewers can choose from HD to lower resolutions, depending on their internet speed and device. And finally, there's transmuxing. Here, the video may be transferred to a different container format, like switching from MKV to MP4, without changing the video's quality or encoding. This step helps ensure compatibility across devices and platforms. Packaging, HLS/DASH. Once the video is transcoded, it's ready for packaging using protocols like HLS, HTTP live streaming, or DASH, dynamic adaptive streaming over HTTP. These protocols segment the video into smaller, manageable chunks, called segments. Each segment is available in multiple renditions or resolutions, so the streaming service can adapt to your network speed in real time. We also create manifest files, which act as guides for the video player. These files tell the player which segments and resolutions are available, enabling smooth streaming by fetching only the parts needed based on your device and connection speed. These protocols are responsible for delivering the video over the internet to your device. And just like that, from raw footage to a polished stream, the video is ready for you to enjoy. Now let's focus on containers. Think of a container as a digital box that holds all the parts of your video, like the video stream, audio, subtitles, and metadata, such as title and duration. By bundling these elements together, the container ensures your device can easily decode and play the video seamlessly. Let's break down some popular video container formats and where they're used. MP4 supports H.264, H.265, AAC codecs, common for streaming on platforms like YouTube and Vimeo, social media sharing, and mobile playback. Files usually end in .mp4, MKV, often used for high-definition video and storage, supporting multiple tracks and subtitles. Common codecs are H.264, H.265, and VP9, with .mkv extensions, ideal for DVD/Blu-ray rips and archiving. AVI, known for digital video recording and playback, especially on Windows, uses codecs like H.264 and MPEG2, with the .avi extension, ideal for video editing. MOV, Apple's go-to format for professional editing, storing high-quality video. It supports codecs like ProRes and H.264 with .move extensions and is optimized for Apple devices. WebM, open source and optimized for the web, using VP9 and Opus codecs. It's ideal for HTML5 video, live broadcasts, and embedding in web apps with the .webem extension. Apart from these, there are other container formats like FLV, 3GP, HEVC, AVCHD, and MPEG-2. Now let's flip this and see which mobile phones support them. All supports codecs like H.264, H.265, AV1. Only Sony smartphones have more options as it has older codecs as well. All right, let's dive into something fun. Did you know you can actually view detailed video metadata right in Netflix? There's a little-known shortcut that brings up all kinds of information we've covered in this course. Here's how you do it. Just press Command plus Alt plus Shift plus D on a Mac, or Control plus Alt plus Shift plus D on Windows while watching a video. Once you hit this shortcut, a hidden overlay will pop up, showing a treasure trove of data about what's happening behind the scenes. Here's a quick look at what you'll find. Resolution. You'll see the video's resolution, which is the clarity level based on pixel dimensions. Here it is, 1920 into 1080. Codec. You'll also spot the codec in use, such as MP4A for audio and AV1 as a video codec. Container. Here you can see that Netflix is using MP4 as container. Frame rate. You'll see the video's frame rate, usually measured in frames per second, FPS, which affects how smooth the video appears. Here it is 23.976. You might also catch a glimpse of the content delivery network, CDN, that's delivering the video. Here's another one. If you're watching a video on YouTube and want to dive into its behind-the-scenes details, you can check the Stats for Nerds. Simply right-click on the video player and select Stats for Nerds from the menu that appears. Just like on Netflix, you'll get an overlay with all kinds of information we've covered in this course. Here's what you'll see. Resolution, which is here 1920 by 1080 with 30 FPS. Codec, YouTube uses AV1 for video and Opus for audio. And that wraps up our journey from source to screen. I hope you found this informative and have a better sense of what goes on behind the scenes in streaming. Thanks for watching, and if you enjoyed this, don't forget to like, share. See you next time.